Hello, my name is Bailey Lassiter, and these are my partners Delaney Story and Kara Snifley, and our teacher facilitator is Lana Sather. I would also like to acknowledge that Trinity Kennard, another team member, could not be with us today. We are from Burleson Independent School District in Burleson, Texas. We are in 6th grade, moving on to 7th grade at Kerr Middle School. We are here to discuss our proposed project on the effects of amoxicillin fighting against E. coli in a microgravity environment. When we first started working on our SSEP project, we watched multiple videos and found that amoxicillin does a good job of fighting off many types of bacteria. E. coli is a bacteria that can cause many illnesses, including respiratory illness, pneumonia, as well as infections of the digestive tract and urinary tract. E. coli infections are accompanied by a wide variety of symptoms such as nausea, vomiting and diarrhea, pain, and fatigue. We also researched previous studies focusing on E. coli treatment with amoxicillin, talked with a physician, and soon became fascinated by how amoxicillin works in destroying the E. coli bacteria. This led us to wonder if amoxicillin would remain effective in the treatment of E. coli infections in a microgravity environment.
We propose to answer the question of how effective will amoxicillin be against E. coli in a microgravity environment. E. coli can be found in animal waste and can travel via water runoff to neighboring fields and to the crops growing in those fields. This could negatively affect the agricultural products, which are then ingested by humans, causing infection. E. coli can also be naturally occurring in the human digestive system, which means astronauts could easily encounter this bacteria. E. coli is easily transmitted via food contamination and personal contact, potentially leading to a large outbreak where people are living in close proximity. This experiment was designed to test the effectiveness of amoxicillin in controlling E. coli infections in microgravity. Since E. coli could potentially be a devastating problem for the ISS and future space travelers, it would be worthwhile to see how well the amoxicillin could do in a microgravity environment. Amoxicillin does kill a variety of bacteria, and by studying how it interacts with bacteria in microgravity would be proven beneficial.
We proposed to use a type 2 FME mini lab. We used 2 milliliters of a liquid amoxicillin, 1 gram of live E. coli, and a nutrient-rich gelatin. In volume 1, we would have put 2 milliliters of a liquid amoxicillin, and in volume 2, we would have put 1 gram of live E. coli and a nutrient-rich gelatin. If the FME mini lab went up into microgravity environment, the astronauts would have released the clamp that is separating the two, amoxicillin and E. coli, which then the amoxicillin would try to cure the E. coli. We would have also seen if we could use a type 3 FME mini lab with a fixative, as they might worked out better. In conclusion, we would know the differences of amoxicillin versus E. coli on Earth. We would try to conclude what the results might be and compare the differences. We could see if working with a type 3 FME mini lab with a fixative would work better. We would look for different turbidity levels and compare. We would have a better understanding on how antibiotics work in a microgravity environment. We believe it's important to know if these medicines work in space, so if an astronaut gets sick, we would know how to treat them. We would have also made the following changes: give more background information with detailed references, prior experiments supporting prior knowledge, more detailed directions using the standardized vocabulary for astronauts' directions, and choosing more appropriate language. We would like to thank everyone who made SSEP possible for us today. Thank you.
Do we have any questions for this team?
Hi, I'm Keith from West Vancouver, BC, Canada, and I'm just wondering, where did you get the E. coli sample?
We talked to a physician, and she said that E. coli could be almost found anywhere. Some could be harmless, and some could just be like very bad strands of it. And pretty much E. coli could be found anywhere. So we would swab something, and we have an E. coli tester that we would use to test the E. coli.
How are you sure you have it so that you know you have an active sample that you're sending into your experiment?
Well, we are just a finalist proposal.
Thank you.